Hello, everyone. A very good afternoon to all of you. I am Sakshi, welcoming you all on behalf of Solar Quarter and First View Group to the first day of Western Africa Solar Week 2022. Hope you all had a great time networking with your peers today. We'll have these networking sessions again at the end of each session. Now, it's time to start with our content. But before that, I take the pleasure to thank our platinum partner, Junko Solar, for extending their immense support to organize this event. I request my team to play the sponsor videos.
Energy lays the foundation of civilization and gives wings to science and technology. Every progress made by humanity has been driven by the reimagination of energy. Now that our planet has come to the consensus on a more sustainable and low-carbon development model, clean energy, represented by solar energy, is now in the spotlight for the potential value it has to offer. Jinko Solar is a solar energy company dedicated to the R&D and manufacturing of photovoltaic products, as well as a provider of integrated clean energy solutions. The company fulfills its mission to optimize the energy portfolio and take responsibility for enabling a sustainable future, strives for world-class quality with Chinese efficiency, and empower a green future with innovation. We forge ahead with foresight. Throughout our 16 years of growth, we have remained true to our founding values, established ourselves in the industry, and stayed in step with the ever-changing market. We were the first to propose the idea of integrated production capacity. Investing in the sections with the most sustainable value in the industrial chain has helped us gain a competitive edge beyond cycles. Based in China, we have built our presence all across the world. Relying on our global sales network and after-sales service teams, we provide high-quality products and localized services to customers in over 160 countries and regions. We are present across all time zones on Earth. We strive to stay ahead of the curve. For many years, we have remained in top spot in PV shipment ranking with over 100 gigawatt module shipment around the world. We've been committed to scaling up new heights. As an innovative leader in China's strategic new industry, we are constantly exploring the possibilities of innovation and replicable applications, and consecutively broke the world record for efficiency 19 times. We are committed to energy transformation. We actively invest in the next generation of photovoltaic technology and explore multiple prospective fields, formulating an effective coordination among our R&D, manufacturing, and sales, ensuring first-time value conversion of innovation. Our hard work has paid off with remarkable results. As a major ruler setter in the industry, Jinko possesses a leading intellectual property system. It is a national enterprise technology center and national technological innovation demonstration enterprise. We keep improving until perfection and aspiring to be known for our supreme manufacturing quality. Relying on the advanced smart production line, we have realized informatization for the entire production process. Our modules have won the title of Best Performed for many years, helping Chinese products to gain global recognition. We always seek for a better future. We're constantly exploring the real-life application possibilities for the photovoltaic technology in a variety of fields, including architecture, transportation, production, and living. With the record-high business performance, the ever-expanding market share, and industry-leading growth rate, Jinko Solar, which has landed on the STAR market, will take advantage of the national technology strategy to create a shared future with like-minded partners. Jinko Solar is honored to take on the glorious mission and opportunities by history to keep leading innovations, fulfilling our responsibilities, and protecting the environment, so as to compose a magnificent chapter dedicated to the photovoltaic industry. Empower a brighter future with solar.
Thank you, team, for playing the video. Now, let us begin with our first presentation. I want to invite Ms. Ivande from Jinko Solar for the sponsor presentation. Over to you, ma'am.
Good afternoon, everyone. Good morning. Good evening from wherever we are connecting from. Uh, Please, just a minute. Okay. Hello, everyone, and it's a pleasure to be here at the West African Solar Week 2022. Please, can you see my screen before I start?
Yes, ma'am.
All right. Thank you very much. As we all know, so I don't bore you, Jinko Solar, who is the one of the largest, most innovative solar PV module manufacturer globally today, and who has diversified their portfolio as well, not just only on PV modules, but also into BIPV, into energy storage solutions, solar water pumps, solar street lights. Today, we're looking at Jinko Solar as a foothold, as a stronghold when it comes to financing and construction, not just residential or small scale projects, but as well as CNI projects, mini grids, and utility scale projects as well. When it comes to innovation, bankability, reliability, innovation, and of course customer centricity, we are very key on that, and we don't joke with our customers from B2B to and as well as B2C. As at the end of Q1 2022, we had reached 100 gigawatt delivered of PV modules across the globe. We have 12% market share today. Of course, that is still increasing across not just the globe, but even across sub-Saharan Africa as well as West African markets. Our core business, as we all know, most people are familiar with Jinko Solar being a core manufacturer of PV modules, the wafer and the cells. But today we've also expanded, into other energy sources because, Jinko Solar is not just a manufacturer, but then we aim at being an energy service provider, ensuring that we meet the needs of every energy demand from the agricultural side to the industries to the residentials to of course the utility scales as well. And that's why we've diversified our portfolio. So now we have not just the PV modules that we're familiar with, we also have the BIP, that's the building integrated photovoltaic, the energy storage solutions as well. When it comes to reliability and bankability of Jinko, that is one thing that we've maintained over the past 6 to 8 years from 2014 till now. One thing is very sure, PV modules tend to take about 40% of the capex of a PV project or of a solar project. And we know that for either the developers or the EPCs or even the financiers of those projects, one thing is very key for them: how bankable this equipment they're using is and how reliable. And so, according to the PV Evolution Lab, which is the PVEL, so far as we've been submitting the samples of our PV modules over the years, we've maintained top level number one on the record for reliability, for bankability, for quality, and for continuous improvement on even the technology we deliver to our customers. Today, we have diversified portfolios even on the PV modules, from the Tiger series to the Tiger Pro and the Tiger Neo, which is the latest model and innovation of Jinko models. The Tiger series is the 163 mm wafer type series, and it ranges from the 380 watts, as we can see here, which is an N type module, of course a better efficiency, all the way to the 475 Tiger series. These are P-type modules, that's positively doped modules. We also have the Tiger Pro, which is the 182 mm half-cut modules, where this one starts from 405 watts all the way to the 550 watt peak. Of course, the efficiency too is high. But then we realized that for the P-type modules, they had reached the peak of efficiency, energy yield, and every other qualification that makes them, of course, very good as well. And so Jinko went, of course, as usual, R&D, which is very top notch for us, and innovation. And then we launched the Tiger Neo. This was launched in Nigeria earlier this year in July. And we launched the Tiger Neo to meet the needs of not just the commercial, but especially even the CNI and the utility scale projects. And this is much more efficient. We'll go more into the details and the peculiarities of the Tiger Neo models. The N-type PV modules, and as I was mentioning, it's a TopCon technology, and here the passivity is higher. Here you're able to get more electrons from the of course the DC power coming from the sun, thereby your energy yield is increased, your performance is also improved. One of the things about the N type modules is the higher efficiency, so you get to see a higher efficiency on your harvest of power from the sun, and in terms of even the productivity or the yield from the panels across the useful life, and even during the day when you're utilizing the PV modules. As well as when we look at the degradation level, it's lower, as well as higher bifaciality. I'll go more into details. In terms of the specifications, we have the 54 cells, wafer cells, which is from the 410 watt peak to the 430 watt peak. And of course, they are all monofacial. We also have the 60 wafer type as well. Now, these ones are very peculiar and very useful for the residential or SMEs, MSMEs kind of project. Then for the CNI project, or larger scale projects, and as well as some utility scale projects, we have the 72 of course 182 mm as well, the 72 wafers type module, both monofacial and bifacial. Then we have the larger types, which is the 78 wafer type, which is majorly very useful and very good for utility scale projects. And most time utility scale projects we know is ground mount, so this is very advantageous for such projects. And then it goes as high as 615 to 620 watt peak modules. Of course, the Tiger Pro, which I had mentioned earlier, is still very much in the market, still very much high in terms of the quality, in terms of the efficiency, and the yield that it gives. When it comes to the power yield on each of our projects. Now, linking back to our topic today, which is financing and construction large scale projects. Jinko Solar is very peculiar about supplying the best and quality of products, both on PV modules and energy storage solutions that meet the needs of large scale projects. One of the peculiarity of the Tiger Neo, in fact, one of the reasons why the innovation went, further to develop the Tiger Neo, is to improve, the useful life and the warranty, the product warranty and the performance warranty on the PV modules. Now, as compared to the P type, where the useful life is just 25 years. For the performance warranty of the Tiger Neo, we're having 30 years. Now, not just even the number of years that is peculiar or advantageous or beneficial for the Tiger Neo modules. Now we look at the first year degradation. The first year degradation of the Tiger Neo modules is less than 1%, as compared to the Tiger Pro modules or the Tiger series modules, which is about 2%, 1.5 to 2%. So here now you can see that in the first year um of your solar system or your solar plant or your solar farm, depending on the scalability or the scale of what you've put down, you are confident that you're not going to be having a major degradation of your panels. And even from year 2 to year 30, we see a linear degradation of 0.4%, which has improved the performance itself, the entire performance across the entire value chain of the project. Now, here we can see here down that before, for the Tiger series, the performance stopped at 84.8%. But now with the Tiger Neo, you can go as high as 87.4% at the end of the useful life. That's at the end of 30 years of your project. So then you're seeing that even at year 30, your solar modules, your Tiger Neo solar modules, is still delivering a very tangible amount of power to your facility. Secondly, we've seen that for a number of even CNI and then, of course, utility scale projects, they're beginning to look at bifacial modules, and that's because for ground mounted systems, when you utilize a bifacial module, you're able to get reflectivity advantage, and which gives you about 1.35% power gain to what you could have harvested from a monofacial system, a monofacial panel. And then so now we see that the bifacial factor goes from 70% to 80%, 85% of your power yield. Then looking at the LID, and then that's the better low light performance compared to the traditional, P-type modules. The N-type module, because of the kind of technology, the TopCon technology, has a better response to low light, and of course you can extend the power generation period by about 1 hour. So you have like 30 minutes in the morning, 30 minutes from the afternoon to evening time. One of the things that we've seen that in the solar world or in the solar space, before things began to improve, people had the mindset that you can use your solar PV modules until it's very bright during the day, maybe like 10 or 11, or when the sun is really high. But then now with the advantage of the Tiger Neo, you see now that even with low light, so once there is daylight from as early as 6:30 a.m., your PV modules, your Tiger Neo PV modules, is beginning to generate power. And that's why you can see the from the charts on my right hand side, possibly I should be on your left. You can see that there's an improvement in the performance, in the energy yield, um, the kilowatt peak per kilowatt hour that you're able to generate from the Tiger Neo modules. Another thing that is also peculiar about the Tiger Neo modules is the temperature coefficient improvement. So here you can see that, especially for areas, some areas in West Africa, let's take an example, Nigeria, northern part of Nigeria, that the temperature could go as high as 44 to 47 degrees C. Now with the advantage where you have an improved temperature coefficient, it means that even when the temperature is quite high, your PV modules will still generate as much as, in fact, an improvement of 15% is even on it compared to the P-type modules. One of the things that we know is the higher the temperature, the lower the voltage, and then it affects even the materials of your PV modules. But now, when with the invent of the Tiger Neo, one, the durability, the susceptibility to even high temperatures is better, as well as the temperature coefficient itself is way better and more improved to accommodate higher temperatures in arid areas that we have a lot in West Africa. So looking at the overall improved energy generation for the Tiger Neo modules, especially for projects, especially large scale projects, we see that we can get an improved energy generation of over 3% as compared to the P-type modules. Now looking at one of the diversified portfolios that we have, which we've seen that a lot of people have been, a lot of companies, EPCs financiers, mini grid developers as have been looking into, which is the energy storage solutions. Both for the large scale projects, utility scale projects, mini grid projects. Um, just to mention a bit, apart from the CNI energy storage solution, which is the large scale project, large scale systems, we also have the residential solutions. So we are not just focused on just a particular market niche, but then we cover from residential all the way to the utility scale. Just looking at this, just a brief explanation of how the BSS works. It is a plug and play solution where everything is all connected together. The battery pack, the battery management system, the energy management system itself, of course, the HVAC and fire control system. Of course, it has the remote monitoring system as well, and everything is all connected, plug and play. So you're not concerned with having to get your PCS, the inverter separately, your battery bank separately, and then having to get cables to connect every one of them together. So it all comes connected, in the same containerized solution. And of course, it works for both mini grids as the off-grid systems and the grid tied systems as well. You can also connect multiple sources to the system. That's both your grid and your diesel or gas generator as well. And so this is the energy storage solution. As I explained, we have the residential storage systems, the CNI, and then the utility storage systems. Just to mention briefly on the energy storage solutions for the residential, there is a single phase and the three phase. Both, the battery, which is 5.12 kilowatt hour, that's a pack, which can of course be paralleled up to 20 pieces as put here, and can also be scaled. Also on the single phase inverter system that comes with it is 3.6 all the way to 8 kilowatt single phase inverter. For the three phase, we have the 8 kilowatt all the way to 12 kilowatt systems that goes hand in hand, working in tandem with the battery. The good part, of course, of the Jinko system is that you can it actually works with multiple products, meaning it is not regimented to just the Jinko systems. So if you have other products like the Schneider, the Huawei, the Sungro and Co, the Jinko system also works seamlessly, and it can be integrated with this system, which makes our system very, very robust. Now, talking about the CNI, which is one of the things we're looking at today, large scale projects. We have from the 50 kilowatts, 69 kilowatt hour, all the way to 500 kilowatts, 1620 kilowatt hour systems. These are standard the standard CNI product. Of course, we have the customized systems that can meet the particular or specific needs of each of our clients or our customers, from the CNI all the way to utility scale. We'll see some of the project references that we've worked on and how large the systems can be. Just looking at the system integration, how it works. This is the grid, this is generator, so it means that you can connect external sources of power to your containerized CNI solution, and you could have your external ATS. The Jinko model or the Jinko ESS comes with its own static transfer switch. That's the STS. Now, this is a an example of a 50 kilowatt 69 kilowatt hour system. Now, the STS, which is a static transfer switch, one of the advantages of the STS over the ATS is that it has, a faster or a shorter switch over time, in milliseconds. And so you're able to have a seamless integration and a seamless synchronization between all your energy sources. Now, in the case where you're having a grid tied or you have, generator connected to your system. It also has the BASS controller where you have the MPPT charge controller in there. You have the energy management system and the BMS, the battery management system as well, controlling seamlessly the entire project. It has an isolated transformer, so you're not worried about over voltage, over current. So it works as a balancing of systems at every point in time. And of course, you can connect your load and your PV. On the right hand side, you can see the remote monitoring platform where you can connect your SCADA system or whatever remote monitoring platform that you have or you're working with. So this is just the description of how it looks inside the containerized solution, inside the cabinet. Of course, I had mentioned you have your hybrid PCS, which can either be DC-DC convert or AC-DC converter, depending on what you're working with, in the end. Now, talking about, as I mentioned earlier, the different or project reference, some of the project references, that we have. This is in China, and this was commissioned in June 2022. And we can see that this is a 20 megawatt hour lithium ion phosphate Jinko panel battery, and of course, a 10 megawatt AC system working seamlessly, powering the entire factory. This is actually a Jinko factory that has gone fully off grid and powered by PV as well as the energy storage solutions. So this is to show that this is not just a talk by Jinko. This is also a do, and it's already a done, in fact. And it's currently active and being in use. This is in Nigeria, and this is in Wuse 2 market. For those in Nigeria, those in Abuja, you could check this out. It's live, it's working well. It's been serving the entire market. It was done by GVE and REA and of course, Jinko supplying both the PV modules and the ESS. This is a 1.2 megawatt hour battery and of course 1 megawatt PV, functioning well, solving the problem of the market, users and the environments around. Also in Mozambique, now, just mentioning other African countries, we have this also a PVESS mini grid project. This is a 250 kilowatt, 690 kilowatt hour system. Now, this is a ground mount, solar plant. So it's not peculiar to just roof mounted, both ground mounted and roof mounted systems. You can, have your lithium ion batteries and of course your Tiger Neo modules on site to give you the best power supply you can ever get, for your systems. This is in Djibouti. This is a 1 megawatt, 1.2 megawatt hour system as well, also live and powering this remote village in Djibouti as well. This is somewhere in the southeast of Nigeria. It's a 100 kilowatts, 100 kilowatts, 192 kilowatt hour system. Also ground mount is also a mini grid, and this was done by I think Darway Coast and working perfectly well. Now, this is just not limited. I mean, these references are not limited to what we have here. We have a good number of projects within Nigeria and outside Nigeria, Cameroon, Ghana, Sierra Leone, Liberia, and in many other, West African countries that we've delivered and deployed, and we're still deploying these solutions to. One of the key things for Jinko West African team is that we are on ground to support. We have both the technical and sales team. We have a big team to meet all the needs of everyone across the West African markets, and we are positioned in different countries of the West African market to cover the market, both from the residential scale project all the way to the CNI scale project. Also to mention that we have a very robust payment term and financing way to support even our clients or our customers so that they can also meet their needs, deploy to sites, meet the needs of course their customers or the end users. And in the end, we are providing this service seamlessly, going through technical trainings even for our customers and end users at the end. And in the end, our key motion or our key vision is to make sure that, across West Africa and of course across Sub-Saharan Africa, we are meeting the SDG 7 goal, ensuring that there's reliable, affordable, consistent, and clean power supply, of course, using solar to all our customers and to electrify Africa at large. Thank you very much.
Thank you, ma'am. Thank you for the insightful presentation. Now, let me quickly take you through the agenda for today. We will be hosting two sessions today. Our first session will be on financing and constructing large scale solar projects. And after that, in our second session, you will hear our panelists discuss how mini grids are electrifying the region. And now, without any delay, let's begin our first session, which is on financing and constructing large scale solar projects. And to discuss this, we have on the panel with us today Ms. Glory from Renewable Energy Technology Training Institute as our moderator, Mr. Sam from Trina Solar, Mr. Michael Rue from Rensource Energy, Mr. Frederick from EcoSource Canada Inc., Mr. Tunde from Greco Power and Energy Limited. This session will be led by Ms. Glory from Renewable Energy Technology Training Institute. I welcome all our panelists on the screen and hand it over to Ms. Glory.
Thank you so much, Sakshi. Hello, everyone. I apologize for the noise in my background, but I'll go ahead to introduce our panelists. Before then, I'd like to welcome you for this session, which is called Financing Large Solar Projects, right? And today we're going to be learning from lots of session experts. And I'd like to to introduce to you the first person. I have with me Mr. Sam Oguniyi, who's the regional sales manager for West Africa, Trainer Solar. And I'll be introducing them as well. I have Mr. Michael Iwu, VP of Commercial Rensource Energy, Mr. Frederick Opoku, Senior Consultant EcoSource Canada, and I have Mr. Ernest Adu Nyate, who's the Business Development Manager for Climate Change Ghana and Eki Energy Services Limited. I also have Mr. Tunde Isiolaiton, who's the Managing Director for Greco Power and Energy. So I would quickly read out to you Mr. Michael's bio. He's the VP Commercial for Rensource Energy and he has over 10 years experience in sales, business development in the renewable energy and power industry. He has a Bachelor of Engineering in Electronic and Computer Engineering from Nnamdi Azikiwe University, professional member of International Solar Energy Society, and is certified inbound sales professional. He's also the founder of Global Warming Shield Foundation. Amazing. Mr. Michael, I would like to welcome you to the call. Thank you for joining us. Please say hello if you're on the panelists.
Hello, can
Okay,
you see me?
and yes, we can. Then I'd like to read out the bio of Miss Engineer Tunde Isolaiton, who is a seasoned renewable energy and energy efficiency expert with more than 8 years of experience. He is involved in construction of power plants and development of nationally recognized curriculum for the Nigerian clean energy sector, as well as implementation of energy efficient low-cost housing. He was the principal expert, capacity development of NESP 2017, where he developed vocational training for sub-Saharan Africa in the clean energy sector. He has provided strategic leadership for Greco Power and Energy Limited since June 2013. Wow. Welcome, Mr. Tunde. If you're here, please say hello.
Hello, it's a pleasure to be here, everybody. Thank you.
Nice to see you. Welcome to all the panelists. So I'll just quickly start with the first question. We are here to discuss the financing the solar power sector, especially large-scale solar projects. So I'm going to be starting with Mr. Michael Iwu. So I'd like you to share with us what has been the blueprint for construction of utility scale solar projects in the region, which is West Africa, and what do you think are the major challenges faced in construction of large scale utility scale solar projects? So I'll take that again. What has
Okay,
been okay? Did you get it completely?
yes, please. I got your question. Uh, Thank you very much, Glory. Can you hear me? Okay,
Yes, we can hear
yes.
you.
In the I will start by telling you that Africa is blessed with about 100 kilowatts per annum, right? It has countries like Mali with very high solar irradiation, Niger, it has Nigeria, it has Chad, For Mali, for example, Mali currently has an energy access of about 40%, and it shows that the gap is huge, 60% connected to the grid. So they are looking at a very bold vision of connecting 30% to the grid, 30% of renewable energy mix by 2030. The same thing with Chad. Chad
Hmm.
Okay, it looks like we lost him a little bit. So whilst we wait for him to get back, I'll go over to you, Mr. Sam Ogunniyi. What are the latest available technologies in modules?
Uh,
Sorry, let me just speak it. No, no, sorry, please. Let me just read the complete question. What are the latest available technology in PV modules, and what are the expectations of project owners in the future?
okay, thanks, Glory. Just drawing from the presentation that Yewande made earlier on, I think most of us in the at the OEM side, the manufacturing, the tier one, we've greatly and consistently been improving on the technology on a daily basis, and of course, this is as a result of the extensive R&D that we all invest in. If we take Mike back a bit to the evolution of PV modules, we remember that there was a time we used to talk about poly type of module and what have you, which was very common in this part of the region. But after some times, we moved from poly, we moved to mono. We moved from mono about 3 years ago or thereabout. We moved to monopec. Now again, we are moving from monopec. We are moving to N type. So in terms of innovation, increasing module efficiency, we've all been increasing. And for specifically looking at what we are doing at Trina Solar and looking at how we can support utility projects across the region. There are some specific things that we've also added to our innovation. For example, if you look at currently, even looking at our rectangular cell module, these are specifically designed for utility projects. The reason is that for utility projects, you are concerned about the space you have. You want to have as smaller as possible the space that you're going to require to be able to do construction projects. And of course, you're also looking at your overall capex experience. At the end of the day, you want to look at, okay, when you look at the major component, the PV modules, the inverter, the batteries, if you're going to use and what have you. Of course, there are still some other components that you also need to consider, cabling and things like that. So at the end of the day, you want to have the best capex experience, and for you to be able to add this best capex experience, which means that you're going to have a reduced LCOE, which is the levelized cost of electricity. So you need to consider, okay, a PV module that is going to bring down the total cost of this. So that's why we have said that from our own end that our rectangular size PV module we greatly reduce the BOS. We greatly increase your BOS savings, which means you can save as much as 7 to 10% of your in time of BOS savings. And of course, looking at your total capex experience, you are looking at you having a savings of between 2.5% and even 5% savings in time of capex. And of course, for those that are very familiar with utility projects, for big scale projects, we know that the cost of these projects run to millions of dollars. And having a 5%, 2.5%, even if it's 1.5% in terms of savings in this regard, it goes a long way in the overall business efficiency.
Wow, amazing. That is so enlightening. Thank you for sharing that. And to all the listeners, I hope you are taking notes. Thank you very much, Mr. Sam. I'll get back to you soon. I'd like to ask Mr. Tunde Isioleton, please, can you share with us what are the financing options available for large-scale solar power projects in the West African region? I know a lot of people want to hear about money, so Please, can you share with us or throw some light on the financing options available, financial instruments, financial types, funders, or whatever you can share around that? Thank you.
Okay. Thank you. I mean, the question you asked me is it's quite broad. I don't know where to start and where to end. I mean, there's obviously the traditional means of funding, which are the financial institutions, the commercial banks, and all of that. But also, there's a lot of what would I say, development funding available through the international development banks, the international finance institutions as well. And also, there's obviously the most traditional way, which is for the end user, the owner of the system, to purchase the system himself directly. We just completed a 1.5 megawatt system, Jinko solar panels as well at in Abeokuta at Obasanjo, that's Obasanjo Presidential Library. And it was self-financed by the past president of Nigeria, Olusegun Obasanjo as well. And so, I mean, these are amongst a few. But then there's also, there's a wide range of where you can mix and where you can match. You can take a little bit from here, you can take a little bit from there, mix it up to come up with something quite innovative. The guys who are in the finance space for these things I find them quite interesting because they always come up with new ideas and new structures for these things. There's also the rental issues as well. There's something I was discussing with somebody just this morning, about how they can rent out the equipment to you, as an EPC or developer, and then you pay over a period of time. So I mean, across board, there's so many, should I say, innovative methods and ways by which financing is done. Yeah, so, thank you very much.
Amazing. Thank you so much. Congratulations on the 1.5 megawatt completion. And guys, you can already see so much collaborations going on already with Engineer Tunde from Greco and Jinko Solar. That's amazing. But thank you for sharing that with us. I will go to the very next question. Um, and this time around, I would like to ask. Sorry, I want to just ensure that all my panelists are on board. Mr. Frederick Opoku Agiekum, are you online? Are you on the call? I don't think so. Okay, I don't think so. So this next question is for Mr. Michael Iwu. The question is, how has technology helped in lowering LCOE of solar projects and making them cost competitive? How is technology helping in lowering LCOE of solar projects and making them cost competitive? You have the floor now,
Okay,
Mr. Michael.
yes, thank you very much. I might not be using my video because of network issues. Okay, so from the presentation of Yetunde, obviously, you will notice that great research is going on the N-type panels, right? So obviously, instead of the 20 years PPA that we normally signed with end users, we can do 25 to 30 years. So the capex that is being invested, by the time you spread it for 30 years, obviously the LCOE will reduced, right? So that's one. Also, with larger panels, it means that you'll be using lesser space and, of course, lesser BOS, right? So it will also ensure that you use lesser capital, right? So this also promotes further lower the LCOE of renewable energy projects. So great things are happening. The efficiency of N-type cell module is about 24.24 compared to 21% in the normal P-type model, right? So obviously, this is lowering the LCOE of project generally.
Amazing. That makes a lot of sense. Thank you so much for sharing that. And I'll go to you now, Mr. Frederick Opoku. Um, I have a question for you, and is this: which battery storage technologies are available for utility scale? We're talking about financial please share with us and with everyone what battery storage technologies are available for utility scale. We know that there are many types of different batteries, each with its strengths. But what can you advise for cannot be the same for utility, even though batteries are similar of advantage. So do you agree with that? For utility scale. Mr. Frederick, are you there? Okay. You're I think you're on mute or your network is not well connected. Mr. Frederick Opoku, please confirm that you can hear my voice. Okay, I can see a signal. Oh, wow.
Hello?
Hi, can you hear me
Hello,
now?
Glory? Yes, I can hear you.
Okay. Yeah, sorry about that. Please, do you want me to repeat the question?
Yes, please. Can you go ahead and then repeat the question for me, please?
Okay, my question was on battery storage. Thinking about large and mostly utility scale project, what storage technologies are available for utility scale, or which ones are highly recommended? And I mentioned that residential scale and utility scale are quite different. And so, are there differences to look out for when thinking about storage capacity for utility scale?
Okay, thank you very much for the question, Glory. Battery storage systems are emerging as one of the potential solutions to increase system flexibility uh, due to their unique capability to quickly absorb, hold, and then re-inject electricity in an efficient and reliable manner for utility scale projects. For utility scale projects, market applications are commonly differentiated as in front of the meter, that is the FTM, or behind the meter, that is BTM. For the FTM batteries are connected to distribution or transmission networks or in connection with the generation asset. They provide the applications required by system operators, such as auxiliary service or network load relief. And then with the behind the meter, that is the BTM, batteries are interconnected behind the utility meter of commercial, industrial, residential customers, which is aimed at electricity bill savings through demand side management. Of course, there are different battery storage technologies that has been deployed in the market, and specifically for utility scale projects, that is including lithium ion, sodium sulfur, and then the lead acid batteries can all be used for great applications. However, in recent years, most of the market growth has been in the lithium ion batteries, with an increasing share in large scale battery storage deployment as opposed to the other battery technologies. For system operators, battery storage systems can provide great service such as frequent response, regulating service, and then the ramp rate control. So, to conclude, what I can say is that most large scale project developers are using lithium ion batteries for project development in the West African sub region. Thank you.
Awesome. Thank you for sharing that. Um, I will have a follow up question for you later. Please, I want to move to Mr. The very first person that we spoke to this evening, Mr. Sam Oguniyi. I have one question for you. Please share with us what I heard that there has been some discussions around Trina solar modules they have been having high string power, right? Can you shed more light on this? Trainer solar modules having high string power. What does that mean? And can you shed more light on this? Thank you.
Okay, Glory, thanks. So just if you look at the way the conversation have been going, again, starting from when Yewande did his presentation, looking at what Michael has said concerning the project that they've done with Jinko, and of course, looking at the project Tunde mentioned in Obasanjo Farm in Nota, which coincidentally some weeks ago I was at that place and I saw the installation. You can see the focus and the direction is about efficiency, is about cost saving, is about how we can optimize and things like that. So again, looking at also internally, we decided that okay, we look at in order to improve our technology. That's okay. So by most of our so currently our PV modules, they are the rectangular cell modules, which is a bit different from the conventional modules that you have, the 182 mm and the 210. So by these, it has higher power. So what this simply translates to is that because of the higher string power, you are going to require fewer number of strings to be able to connect, and because by fewer number of strings, you can, and because of the higher power of the module, you can connect more PV modules per string power. So basically, and if you have fewer string, you are going to have, of course, fewer Y connector, and of course, you have fewer Y connector, you are going to have a shorter cable. So at the end of the day, if you look at the journey, the way the narration is going, is fewer, lower, even though you're going to have you have a PV module that have a higher power string. So what this translates to is that at the end of the day, you're going to require a lesser number of cable, and of course, this still translates to better BOS. You are going to have a lot of savings because in terms of BOS, the balance of system that you are going to require to be able to construct your project, you are going to require lesser, which is of course translates to dollar a cent, naira and kobo, as my people in Nigeria will say. So yes, higher string power. Yes. The PV modules that we currently have in the market, which is our mainstream, have higher string power, but of course, it's translated to lower BOS. And if you look at projects, of course, finance. I'm happy that part of the discussion here is also around a subject around financing and all that, because at the end of the day, you want to look at what is the total cost, what is your levelized cost of electricity and all. So this all these components improve technology, and I'm happy. Even if I may add that, even if you look at the N type, the P type, and all that, most of the time, in terms of a string power, they are almost the same. But the rectangular cell trainer solar PV modules have a higher string power, which means that so again, it's about how we can improve the efficiency, how we can improve in terms of capex experience. And one other thing that I think I want to mention is in terms of power to weight, which is also, of course, better power to it. And if you look at specifically for this particular module, we have up to 570 watt peak. So if you have up to 500 watt peak as on a single module, which is not even a N type but a P type, and it means that in a 40-foot container, you are getting about almost 400 kilowatts in a 40-foot container. We all know the cost of freight from China to every other African countries, how it's been going up. I think we are lucky that in the last few weeks, the freight cost has reduced a bit. But what's the overall objective is that how do you optimize your freight costs and all that? So if you have a PV module that you can transport almost 400 kilowatts in a 40-foot container, compared to what you get in maybe in the mainstream about 250, 300 kilowatts. So again, at the end of the day, because to do large scale utility projects, we are talking about I mean, in some cases about hundreds of containers of PV modules. This is only on the PV module alone. So where can you optimize this the quantity of energy that you have in the container and all. So at the end of the day, again, this all translates to reduced overall capex experience.
Wow, amazing! Thank you for sharing that very enlightening response. So I'll go over to you, Mr. Tunde, please can you share with us, because you just told us you finished a 1.5 megawatt. That's amazing. So how does O and M? Sorry, I want to be able to read it properly. How is O and M done for utility scale projects, and what is the best model for the West African region? Right. I believe that from your experience, you'll be able to tell us: is there a specific model to follow? Is there a best practice for conducting O and M for large projects in the region?
Mm. Um, I cannot comment and say there's a best there's a specific model that's for West African region. I would say every project is unique, right? And the O&M strategy and the O&M processes have to be designed along with at the time before project is even implemented, right? While the project is being designed, the O&M has to start to be considered. You know, there's a lot of things that have to be considered. You know, the type of equipment that is being used, the OEMs recommended OEM practice, the practices for their equipment. You know, there's also a huge financial consideration as well as far as the O&M is concerned. Also very key with O&M is the monitoring and control, right? The remote monitoring and control is very key. Also depends on how large the system is, right? Like for instance, with our system, it's a system where we've had to step up energy power or voltage to from the 400 volts to and then distribute at 11 kV, right? And so when we are working at medium voltages, you know, the O&M requirements and O&M operations are totally different from when you're working at the low voltage end user level, right? Transformer require a certain type of management. We have to with RMUs, and then also there's also the integration and synchronization with the existing equipment, right? I would not be able to say I would not say oh there's a specific or a particular method or model for O&M. What I believe is and what I would say is every project's O&M has to be considered as a unique case, right? And O&M has to be also be considered. Obviously, O&M has to be considered at the time of equipment selection. When you select the equipment, then you begin to think about the O&M, right? And also, while you're selecting the equipment, obviously, as you're selecting the equipment, you're considering the electrical power assets on ground, right? Are there you know, like I said, is it a medium voltage system? Is it a low voltage system? How is the energy being distributed? How the power being distributed? You know, are you burying cables? Are you putting cables overhead? What type of, you know, what materials and equipment are you using? Now, this determines how you factor in O&M, right? Because then you want to see, oh, do we want to have, and then how remote is the location as well? You know, do you want to have engineers and technicians on site 24/7, or you know, or is it a closed facility, for instance, whereby you can train maybe the resident maintenance crew for the customer, the end user, to do basic O&M or basic management, like for instance, just maybe cleaning up the modules regularly, and then you do the more typical maintenance and operations via the remote monitoring system. You know, so I mean, it's quite a complicated issue whereby there's no one size fits all solution to the O&M. It's more of a, should I say, a discussion which has to start from the time the project is conceptualized and finalized, and when the system design is being drawn up with the view for O&M implementation. Obviously with the cost implications as well, right, and as well as also the operational aspects of the O&M, right. Thank you very much.
Amazing. Thank you so much for sharing that amazing response. I'll go to the next person, Mr. Michael Iwu. Please, what can you say about the technological breakthroughs in inverters? Have there been any tech breakthroughs in inverters, or which technologies are preferred by developers? right? I know that
Okay.
recently there's, yes, please, you have the floor.
Okay. Okay. Thank you. Thank you, Glory. Yes. So there've been technological breakthrough in inverters. We have smart inverters now. Um, Unlike how we started, now we have ESS with inverter inbuilt in the as a containerized solution. The inverters are able to communicate now. So easily we are moving to the point whereby we can have inverters that we easily integrate with unstable grid because it will be able to communicate with the stability of the grid. So there have been advancements around inverters. Okay, so this will definitely break open the CNI market, which is doing right now. You can see the Jinko ESS. We know we have the Alpha ESS and the rest, right? And also we have solutions for the utility scale project. Now we will be able to effectively integrate energy storage system to the grid, saying that the inverters are now smart. Thank you.
It looks like we lost him a little bit. So Michael, are you there?
Yes, I'm here. So what
Okay, you've
part did you
completed
lost
what
me?
you were saying. All right,
Yeah.
thank you so much. Thank you so much.
Okay. You're welcome.
So next I'll go to Mr. Frederick Opoku. Um, my question for you is this: what is the best way to select the structures and trackers for your solar projects? Which are more favorable? Which ones are more favorable for the country's market? So structures and trackers for your solar project. Then which ones are more favorable for the country's markets? I hope you get the question. Thank you. You have the floor now.
Okay. Glory, thank you very much for the question. A number of tracker suppliers with different tracking technologies are present in the market, and this has created a need for developers within the West African sub-region to evaluate the right technology, keeping in mind factors such as ease of installation, maintenance, availability of spares, reliability, life cost. Selection of a tracker, selection that is a poor selection of a tracker can significantly undermine the benefits of using them and can cause significant installation, maintenance, and reliability issues. So there are some few decision metrics along with their influence on the selection of which structures and trackers to use. Now, the first decision metric that I would like to talk about is what type of tracker are you supposed to select as a large scale solar developer. Now, um, first decision is exercising the choice between a single axis or a dual axis tracker. Whereas a single axis tracker moves only in the east to west direction vertically, the double axis tracker can rotate horizontally as well as resulting in greater energy generation. The additional investments made in upgrading from a fixed to a single axis tracker can is roughly around 2 to 2.5 against the ratio of only 1.2 to 1.25 in using double axis trackers. Also, maintenance cost incurred on dual axis tracker is much more than the single axis tracker due to greater complexity beside additional land. Hence, at present, it makes economic sense to use the single axis tracker. Uh, Another metrics, decision metrics, maybe I would like to talk about is the tracker configuration. Next decision is to finalize the configuration. There are two main configurations available in the market, namely the building block, that is the BB, and the independent row. Whereas the building block essentially connects a single driving motor to multiple rows of motors. An IR type has one more motor per row. And then the independent row tracker provides at least five main advantages over the building block type tracker. Now, the other ones that I would like to talk about is ease of installation. Another important consideration is the ease of installation, both structural and electrical. The tracker design should be simple enough so that it doesn't add any additional time or need any special training for installation. On the electrical front, absence of inbuilt power source for trackers could significantly increase site cabling requirements. Well, uh, apart from all the factors or the decision metrics that I've just spoken about, it will be wise to also confirm whether the material used to for the structure and the tracker design are suitable for your local environmental conditions, including the corrosivity of soil, the humidity, the irradiance in, and then or the velocity. There should be some form of environmental testing done for the design or more reliability test to prove the suitability of your selection under a harsh site conditions. Because if well, my experience as a consultant with most of the developers, some of the sites are very harsh. There are a lot of difficulties when using these trackers, and also the high radiance of the sun in the West African sub-region calls for most developers even developing large-scale projects without the use of trackers, because already the sun is shining enough within the West African sub-region. So most developers
Yeah.
within the region are not using trackers, but yet they are able to maximize a lot of energy, and they're also able to optimize a lot of energy. Thank you.
Thank you. Thank you for that enlightening response. Thank you so much, Mr. Frederick Opoku. We have one more question for one more panelist, and then I can see that we have some more time remaining. All panelists can now, I'll throw the floor open for any panelist who wants to add something additional. So I have one question for you, Mr. Let me scroll and see the name. Mr. Sam Oguniye. The question is, how are solar projects tendered in West Africa? What is the impact on technology procurement and construction? Tendering solar projects in West Africa. Like, can you share anything at all with us? Is there a model or a template or the best practice that you can share? And then what is the impact of this on technology, procurement, and
Uh,
construction?
yeah, yes, I think if you look at the trajectory of project development in West Africa, especially looking at the last 5 years, we can see that on a daily basis that the adoption, the investment, the funding is increasing by the day. If I remember that maybe like 5 years ago, if we are talking about utility project in West Africa, it was something that was very strange because I remember then I was working in one of the other PV module manufacturing company, and I think then doing a 1 megawatt project was like, whoa, it's like, I mean, people would be like, this is a huge project. But you can see that over the years in Ghana, for example, they've commissioned a 50 megawatt project. They are working on another 250 megawatt project. We can see some projects coming up in a Sierra Leone utility project and all that. And even in Nigeria, early this year, Paras Energy did I think a 10 megawatt project in Abuja. I know that I think if I'm correct, I think uh, uh, Rensos is working currently on a 5 megawatt project and all that. So we can see that in terms of utility projects, of course, we are not yet at the gigawatt club of what we have in Southern Africa, or we have what we have in the northern part of Africa. Yes, we are not there yet, but again, we can see the a lot of utility projects springing up. So in terms of regarding tenders, regarding tenders and those opportunity, for those of us that have been following the development in the sector, we can see that on a regular basis, on a monthly basis, those tender, those opportunities are available, are coming up, looking for. And the good thing is that most of the criteria is looking at of developers, local developers that can actually come in, whether as in time of a JV with international developers to be able to put up this project. So yes, we've been seeing a lot of increasing. I think at the moment, if I'm correct, there is another tender for 50 megawatts in a total of 150 megawatts, 50 megawatts in 3 places that is coming up in Ghana. And I think also in Nigeria, there's a tender of that came up recently about 250 megawatts, which is going to be the biggest solar project in West Africa for the 250 megawatts. So we can see in terms of this adoption, in terms of opportunities, of course, which means that for investors, people that want to do investments, for those that are looking for project to finance, I think West Africa is the green place that most people can come in to invest. And looking at the technological part of it, again, I always draw from what Jinko also presented earlier in terms of technological advancement. Of course, Yewande also mentioned about bankability of the equipment manufacturers that you are using. So for those of us in tier one, of course, we are becoming more dominant, we are becoming more prominent, we are expanding. I know for sure that Jinko has representative in most of the West African countries, same with Trainer Solar. So in terms of quality bankability OEMs, we are entering the region where, why? Because we've seen the opportunity and we are and we are investing in this region. And of course, it now takes us to the technological part of it and adoption. So for all the projects that I've mentioned, the one that was done in the 50 megawatts in Ghana, the 10 megawatts in Nigeria, the 5 megawatt that Rensos is working on, and the 200, the one in Syria alone, I think 25 megawatt, and what have you like that. You can see that almost all of them, all of them, not almost all of them, use tier one PV module modules for their project. So in terms of technological advancement, I think yes, we are adopting it before, because for those of us that are very familiar with solar projects in the past, if you remember, if you take about 10 years backward to the solar project that we knew in our region, there are those street lights that never worked, that were commissioned by government, that probably they worked on the day they commissioned them. So these are the experiences that people in the region have had before now. But because of the presence of the tier one players, the banking companies like company, we are seeing a lot of adoption in terms of technology. Of course, in terms of price, this price between the tier one and tier three is not the same. But if you look at the end results, if you look at the overall project, you want to look at the reliability, you want to look at the durability, you want to look at the lifespan of your project. Of course, you agree with me that investing in a tier one in a bankable OEM is actually a great way. And of course, the financing institutions, those that are financing these projects, if you don't use a good, if you are not adopting, if you are not using any of these tier one manufacturer, they are not going to finance. I can see that in the Q&A box, I saw one of the questions that was there is that everybody is talking about CNI utility projects. In one of the questions that is there, I think one of the reasons, just to respond to that, is that for small projects, there's always tendency for that installer to want to go and use a product that is not bankable. And if you are using a product that is not bankable, I'm not sure there's any investor that wants to put his money on that. So yes, technologically, I think of course, we are not yet there. The tier three are still flooding the market, but of course, for the key projects, especially the one that's been funded by the RA, the World Bank, the GIZ funded project, the USAID funded projects, almost all of them, you have to go with the best technology, which mainly.
Thank you so much, Mr. Sam.
Thank you.
Thank you so much for sharing that. Thank you. Very, very detailed response. That's all for now. We've been able to cover all the questions. I'd like to thank all my panelists. I mean, this has been like a very serious lecture. Thank you for your time. Thank you for sharing this with us. I think it's time for questions now, Sakshi, if I'm correct. Or do
Yes, ma'am.
we? Okay, please, if you have questions for any of the panelists on anything that they've talked about, please feel free to. I think I will let Sakshi take over from here for the questions, right?
Yes,
I
ma'am.
think people can write on the chat box or they can talk, they can unmute their mics. Which one?
Yes, ma'am.
Yes. So
Okay.
over to you, everyone. Please ask your questions now.
Okay. Thank you, everyone, our esteemed panelists, and especially Miss Glory for superbly managing the session. You were absolutely outstanding. We'll be screening a few questions here, and all of you are open to answer it. Here.
Okay, can I read that out?
Yes, ma'am.
And it says, when are you planning to enter the Cameroonian market? There is an absolute need for alternative energy sources in Cameroon, and it is easy to navigate through the regulatory framework for the distribution and sale of small energy generation plants. Omo. He's asking this question to Omo. I don't know if we have that person on the panel, or I mean I think that any I don't know what you think we should do,
Yeah,
Sakshi. Who can answer the question?
yeah. Let me let me answer that question. I think Omo reminds me of a slang in Nigeria. Anyway, yes. So yes, Cameroonian market, right? I know I went to Cameroon to do a project. It was supposed to be a 600 megawatts with Privida. That was the first company I worked with, and I stayed in Cameroon for a while. The regulatory framework is not as easy as you said, right? It will shock you to know that even till date, that project has not kicked off. I'm talking of about 10 years now, right? So it's the same challenge that we are having in most of these African countries. The policies and the bureaucracy is just crazy. Okay, for example, just to add to, I know I was talking about the blueprint for the West African market. In Nigeria, recently, the president launched the energy transition plan. Right, with that plan, there's supposed to be a 42 gigawatts of energy that will be of electricity that will be added on centralized on grid, right, and a 6.3 gigawatts to be added before 2030. Okay, so that would translate to be that you'll be having 800 megawatts yearly within the next 8 years. But is this going to happen? We don't know. So this will take me to that first question I was trying to answer before my network went off. The challenges. Why are these projects not happening in Nigeria and every other West African and even African countries? Number one, the grid. We have unstable grid, so it is difficult to inject utility scale projects to the grid. And two, the tariff is usually not cost reflective. Okay, even in Cameroon that you mentioned, the tariff is almost insignificant. Will you be paying investors? Is not attractive for investors. So the government needs to look at it to make the tariff to be cost reflective. At least let it reflect what is being invested. For example, you will not tell me, for example, to generate electricity using my diesel generator and it's more expensive than selling to the grid. Okay, so that is not possible. So the government must tackle that policy to make the tariff reflective. Okay, and also the other challenge is the bureaucracy and several kickbacks you have to give. It is, sorry to say it, I was thinking it's worse in Nigeria. I think it was even worse in Cameroon, right? So you want to set up a solution that will better the people, but they expect you to settle a lot of people before you do that. So that's the major challenge in Africa, which I think we need to fix. Thank you.
Thank you, Mr. Michael, for stepping in and sharing on that subject matter. Please, can we have any other questions posted on the screen? Thank you. And it says it seems the major focus of most energy solutions is targeted to SMEs and MSMEs who have the financial capacity. Most residential users cannot afford the initial capital outlay required. What financing options are available to this group of people? This group of customer groups, which is residential users. Please, can I call up Mr. Frederick? Can you respond to that? Thank you.
Okay, thank you very much. I think now the attention has been consumers, right? Well, for residential, I think that you can take advantage of some of the crowdfunding platforms that are currently online, and then because for residential, most traditional banks might not fund such projects, and so as most traditional banks see the some of these solar installations quite risky, especially within the African region. So I would suggest that maybe for residential projects, you look into crowdfunding platforms for some of these funding opportunities. But aside this, there are also other funding opportunities you can look to, which is debt financing, which there are also a few companies that are giving residential debt financing for some of these project deployments. Thank you.
I thank you for sharing that. And I'd like to also add to that and say that for residential use, there are these interesting partnership with banks for the financing of your solar systems. And so if you meet the requirements of the banks, I don't know what the country that the person is asking for, but this is available in Nigeria. So you all you need to do is to approach a solar energy company that has that kind of partnership with a bank, and the bank can fund your solar system if you meet the requirements, and then you will have to pay the bank back gradually according to your agreement. I hope that that is helpful as well. Yeah, I think the person is asking for residential solar use. So just in addition to what Mr. Frederick have said, thank you for that. Do we have any more questions? Mike, thanks for taking Omo's question on coming to Cameroon. However, you were talking of large scale projects, but I was referring to small scale consumer energy alternatives and talking about the regulatory landscape being difficult. I think he did not complete that. So, regulatory landscape being difficult for small scale consumer energy alternatives. Um, I think Mr. Mike is already gone from the call. Anyone wants to respond to this? It's more of a, okay, Mr. Michael, you're still here. Do you have
Yes,
anything to say
I'm
to
still
this
here. I
person?
think is a comment he's making. He's talking about um, small scale. You know what interests people to enter a market, right? Is the need for that solution, right? If I'm to enter a market, I will look at a market with lower energy access, right? Even among the rural community, it will interest you to know. It's not like I'm saying that Cameroon is not a good place to go to, right? That's not my point. But there are other uh, countries that I would have prioritized based on their regulatory framework, one, and also based on the need. Okay, for example, Cameroon has close to 70% energy access, and the power requirement, power availability in Cameroon is far better than places like Mali, right, and Niger. Niger is having about 9% energy access, right, with good better solar irradiation. Okay, so investors will want to look at this. I know BBox, for example, BBox is trying to come into Cameroon. That is something that you can look out for. Is an SHS system which you can easily afford. Is targeted at the rural community. So I hope I've been able to answer your question or give you better knowledge about it. Thank you.
Amazing. Thank you so much for stepping in again and responding to that. Thank you for your
Uh,
question, by the way.
hello?
So, do we have any other question? If not, I think I'll just hand it over right now to Miss Sakshi, in the absence of any other questions.
Yes, ma'am. I think Miss Ivana would like to add something to
Okay,
this.
hello, Gloria, can you hear me?
Yes, sir.
Yes, we can hear you.
The chat does credit scoring use a combination of
Okay,
liquid and
can you
precision
hear me?
analytics scoring
Good
Yes,
key
Miss
afternoon.
Ivana, please continue.
Okay,
We
Yes.
can
so
hear you.
Yeah,
I
Please go
guess
ahead.
yeah, one.
okay, so I guess I was the more that
credit
Gerard
scoring
was trying to
for
address the
who has
question
not
Thank
to.
you.
knows
But
about
thank you, Mike,
liquid
for
Federating
answering the
to
question
add
very
is that
robustly.
share
Um,
project
I don't
mechanism has been.
know, Gerard. If you
it's
mind,
liquid.
you could
Oh,
please share your
That's
mail
that's
in
hello, yeah.
the
So what I was
Q&A
saying
box,
was that
and
for
we could also
residential
discuss
projects,
so
extensively
the
what
regulatory
apart
mechanism
from
within
this
the West
stuff.
African sub-region
Currently,
has
Jinko is in
been lengthened.
Cameroon, and of
The
course, still expanding into the
challenges
Cameroonian
these
market.
monitoring
So we look
within
forward
the
to, of course,
region
having more
has
established
to
markets, both from the residential to the SMEs to the CNI, markets or projects as well. So we are open to every segment, every market segment of the solar market as well in Cameroon. Thanks.
okay.
All right. Thank you so much for that. The show is not over yet. We are now taking a short networking break here, and we'll be back with another exciting session on the topics of how mini grids are electrifying the region. Till then, please explore our exhibition lounge, network with your peers, and join our sponsors at the networking tables. Thank you.